Welcome to this short video presentation on alternators for Unit 8 of the Jersey Progression Diploma on Automotive Studies. So the first thing is, what is an alternator? Well, an alternator is a device that's going to turn the mechanical energy from the engine into electrical energy. And that's what we're going to use to run all the electrical equipment on the car and also to charge the battery. Looking at the main parts of the alternator has a rotor, which rotates inside, generating a magnetic field. It has a stator, which is the windings where the electricity is induced. It's got a rectifier that's going to convert the AC voltage that's generated inside the stator to DC that we need to charge the battery. It's got a voltage regulation device, the voltage regulator, that will stop the alternator from overcharging, and typically there's going to be 1 or 2 fans to keep the alternator cool. I'm running through that again, starting off towards the left with the pulley that's driven by a rubber V-belt or multi-V belt of the crankshaft. You've then got the drive end shield or drive end case, a roller bearing that the rotor runs in, one of 2. The rotor itself, and pay particular attention to the claw shape of the rotor, and you can also see in this particular instance the 2 fans mounted to the rotor, the second roller bearing, followed by the stator, the part where the electricity is induced into, then the end shield or end casing, followed by the regulator, the rectifier and the end cap. With the back of the alternator taken off, you can actually see the regulator with its brushes that are in contact with the slip rings. They are on the back of the rotor. And you can also see the diode rectifier bridge, all from the back of the alternator there. And that's the part that's actually going to convert the AC voltage to DC voltage. So first of all, just a quick look at the regulator. The regulator is sort of the brains of the charging system. It's going to monitor the battery voltage and also the stator voltages. It's going to increase or decrease the current that allows it to flow through to the rotor assembly, and in doing that it generates a larger or weaker magnetic field that increases or decreases the current that the alternator generates. Now, the way it gets an electrical connection to a rotating component is through the brushes, and you can see in the picture here the 2 brushes that actually slip over in contact with the 2 slip rings you can see on the right hand side of the image. So as the rotor turns, those brushes slip against the slip rings, hence the name, and we can actually have a positive and negative connection there at all times. With the 2 halves of the alternator case separated, we can see here the rotating rotor assembly. You can see the fan there, and you can also see the stator windings there. With the rotor removed from the case, you have a better look of it here. And the rotor itself is basically a coil of wire with an iron core or 2 claw-shaped iron pole pieces wrapped around it. You can see on this particular one it has got the fans attached, but they don't have to be that way. You've also got a better image of the 2 slip rings on the sort of bottom left of that picture. And you can see the bearing that the rotor is going to spin on as well. There's one at the other end. Now here what we've got is a bit more of a close-up of those iron claw pieces, and you can see if you look in between the claws you can actually see the winding that is going to generate the magnetic field. Now it's arranged in such a way that each of those claw pieces is going to be a north and a south pole alternating all the way around. So this has got the ability to create a strong magnetic field, and that magnetic field is going to rotate at engine speed inside the alternator, and that magnetic field is going to cut through this part, the stator. So what we have is when the engine's running, we've got this magnetic field turning inside that stator, and whenever we have a magnetic field cutting through a wire, we induce a current, an electrical current inside that wire. Here you can see there's lots and lots of wires, and we're going to make a strong electrical current in those. Now, the drawback of this is what we're going to generate is an AC current. Now that's going to be no good to us, because if we connect that up to our battery, it is going to try to put voltage in and then take it out, put it in, take it out, and the end result will be the battery won't charge. The red line you can see there represents 0 volts. And you can see each of the waveforms, A, B and C, actually goes above and below that 0 volts line. And you might be asking, why the 3 phases? Well, that's to give us a nice smooth, or as smooth as possible, steady voltage that we're going to need to stop electrical components and electronic components pulsing. So the question is, how can we actually get this AC voltage into a DC voltage that we can make use of? So this rectifier pack actually contains diodes. Now, diodes are little one-way valves for electricity. The symbol on the right-hand side of the page there is what you'd expect to see, and electricity can only flow in one direction, the direction of the arrow. The diode will actually block the flow coming the other way. Now, whilst the actual rectifier normally contains more than 6 diodes, 6 diodes should be enough for you to have a good grasp of what's going on inside with these diodes. On the left-hand side, you can see the 3 terminals from the 3 different windings of the stator, and you can see that they're all connected to the center of this 6 diode pack, one between each of the each pair of diodes. Now remember what we said, this is actually generating an AC output. So at each one of the ends of those stator, of these windings, each one of those is going to go positive, then negative, then positive, then negative, just like our waveform did. So it's important that we've got some way to make sure that the correct one is connected to the battery at the right time. And the way we do this is by using that diode pack. And if you start off with the green line following from that it's actually from Earth, it's supplying an Earth path all the way through to that negative connection on the left upper winding of the stator. The lower winding of the stator, however, is now positive, and it's pushing electricity all the way through in between those 2 diodes. It can only go one way, in the direction of the arrow. It's blocked from going to Earth, and that then goes through to our battery. As the rotor turns inside the stator, and continues to turn, our lower winding on the stator now has gone negative, and the upper right one has gone positive. So now the Earth path comes through the actual 2 diodes that we were looking at that were positive a minute ago. It's blocked from actually getting through to the battery, can't get back that way. But the next one up, the red line, you can see works exactly the same way, and actually gives us our positive voltage through to the battery, blocked from getting back through to Earth by the action of the diode. So the last part we're going to look at is the actual voltage regulator, only briefly. And the purpose of that voltage regulator is just to control the output. So the problem we would have is with the alternator turning at engine speed, a charge rate that would be fine at idle would be too much at maximum RPM. So there must be some way of controlling it. And the way it works in an alternator is by controlling the strength of the magnetic field in the rotor. And this is known as the field current. So what happens is the voltage regulator monitors the voltage coming out of the alternator. When it senses that the voltage is getting too low, it increases the field current, giving you a stronger magnetic field inside the rotor, which gives us a stronger output from the alternator, charging the battery. The reverse is true as well. If it detects that the alternator is overcharging, there's too much voltage coming out of the alternator, then it reduces the field current, weakening that magnetic field and reducing the alternator output. So I hope that was useful to you. Please remember to download the actual links page that I've sent to you. Have a look at the other videos. They will help increase your knowledge on some of the smaller areas and give you a good look at the testing of the alternator. And from there, there'll be a short quiz just to check that you have actually learnt this material. Thank you.